academic, wherever they come from, and give an opportunity for everyone to kind of meet and mingle. I saw in Toronto and Montreal, they have such thriving AI communities out of the workplace that I think we really could try to replicate here. We have so many professionals across the industry in this region, but I feel there's very few opportunities for people specifically in AI and machine learning to mingle, share their experiences, their research, and kind of have a chance to just like do a mixer style thing after. So this was our first meetup. We wanted to do a little bit of a feeler to kind of see if people show up, if we don't really over advertise it. Next time we'll see if you guys return and keep coming. And I think we're looking at doing a large variety of different events. So maybe a hackathon themed around AI, but partner with some organization this fall in the region, or else just keep doing these style of meetups. So I'd also like to welcome Naveen to quickly come up here. He's been amazing on the Google side for letting us do this in their space, for kind of sponsoring the event. So yeah, welcome up, Naveen.
Thanks. So thank you. As Dexter mentioned, my name is Naveen Nigam. So I head up developer relations in Canada and parts of the US. And I'm really excited that we finally have a GDG, a Google Developer Group in Waterloo. Just considering everything that Waterloo has, I used to be in Waterloo. I went to the University of Waterloo. I worked at BlackBerry for 10 years, so I'm very familiar with the area. But having this in Waterloo is kind of special for me. And my goal is really kind of spread this across Canada and really do more. So as Dexter mentioned, there's a lot of AI machine learning focus with this meetup. And we want to continue that, but we'd love to hear from you as well. If there are other topics you're interested in, if there are other communities that you wish existed, I would love to hear that. My team really is focused on going out in the community, seeing what the community needs, and providing that to the community. And really then enabling and empowering the community to learn from one another. So I will share my contact actually through this meetup as well, so I'd love to hear from everyone, but really glad everyone's here. And I know Dexter's organized a great event and has some great speakers already lined up, so I'll hand it back to him, and we'll look forward to talk to every one of you. Cheers.
I'd love to have Mary from After Up as our first speaker, and then if you guys want to save, we'll do questions after, is like an extra 10 minutes, and then we'll have another speaker after that. So yeah, make sure to get you set up before I go down.
Introduction, and my talk today is titled Data Pipelines in the AI for SaaS Applications. I will mainly be sharing some of my experiences that I have for working in data for the last 6 years. So who am I? So the question that I get a lot of times is actually, how did you get started in data? And then I always said, like, thanks to my education. So I did a bachelor in engineering. Next I did a master's in computer science, which was actually focused on large-scale mathematical simulations. And then finally I did a PhD in medical image computing. And that allowed me to get started in my data experience. So first as a scientific researcher when I was doing my PhD, and then I was working closely together with medical physicists and dentists. I will explain a bit more about that later on. And then when I moved to Canada 8 years ago, I first started working at Maluba as an NLP developer. For a while I was working as a data scientist at D2L. Then I moved to a really tiny startup, Funnelcake, where I was first a senior data scientist and later on director of data science and engineering. Then I wanted to move to a bit bigger startup, so joined DocIQ, where I was a senior data engineer, and since last week I have joined Maptin as their software development manager for analytics. So if you can actually summarize my experience, I have worked at a lot of SaaS companies, which had a B2B focus, and company size ranged about 600 to 800 people. And the interesting part is, like, data teams always tend to be pretty small, with a variation from 1 to 8 people. And actually the 8 people was when I was at DocIQ, where we were like a team of 30 people, where we actually had like a pretty big data science team. So how did I actually get started? So the main question that I was answering during my PhD was when dentists or buying a dental scanner, they're measuring bone thicknesses on their radiographs, or the thicknesses as close to reality as possible. So a challenge what you need to have then is like you need to have accurate objects that you can scan, and then you actually, so you need to have accurate objects that you can scan. So you see an example on the left, and that's a CAD model of the object that I'm scanning. I'm defining measurement lines at lots of places. Next, I put the real object in the scanner. I match up the scanned object with the CAD object, what you see in the middle, two slices, and then I provide like a measurement line, and then you can see on both places you can measure the thickness of the white block. And if you're looking in a 1D profile, what you see completely at the right, then you can compare the thickness. Is the thickness actually really the same, yes or no? Or how much differences do you have? So you can see you can do that for all the different measurement lines, and in that way you can say, okay, this is the accuracy of my image. You can do variations on different input sizes, and in that way you can actually rank your different images and say this is the perfect setting for your patient. So this is academic research, so the focus is indeed reproducibility and accuracy. Also, you always need to keep in mind the deadlines are pretty tight if you have conferences that you're submitting to, so the focus is always making sure that you can generate your images as fast as possible. And also, when you're at the end of your deadline, you don't want to quickly scan an extra image, because then you're also in trouble. And the final goal is like making sure you are innovating so that you're published. So how does this actually relate with SaaS companies? So if you have AI applications in SaaS companies, your expectations from customers when they will buy your product is always, how does it look like for me? Will it actually be working for me? Because you can show like a nice demo, but if it doesn't work for them, they might not be buying it. Next, you have the question, so the model has run for a while, did it actually work for me? And also, will it keep continuously working, and when something is breaking from your data model, why is it actually breaking? So for being able to answer these questions, we need to build data pipelines, and we always will have like a lot of tools available for us. So we might have SQL data, we might have Elasticsearch data, we can use Python. Sometimes we have cloud available. Sometimes we only will be able to work on a PC. How does the customer wants to see his data? Does he want to see like a really fancy UI? Or is he for an MVP just happy with the Google Sheets? Will he want to be kept up to date through email? And what timeline do you have to actually provide results to your customers? So do you need to have a quick demo ready by the end of the week, or is it just a monthly routine thing that you can automate? And also, if you see that your things can automate, so how can you actually avoid that tedious work in the future? And also, as a data scientist or data engineer, it's also important to know which tools actually currently are cool, because you also want to keep up to date and don't want to get behind. And also, indeed, we never can forget the business context. So if you want to answer what does it look like for me, will it work for me, as a question from the customer. So this is mostly like in a sales context, either you want to sell like a new AI tool to a customer, or for example, your customer is already using the SaaS application for a while. You have now gathered a lot of useful insights and data, and on which you will be able to provide insights. So how will you be iterating on that? So like either you have like a lot of data available to the API, to the SaaS application, or you have, for example, with sales data, data that you can pull from an existing API that they're using. It's important that you just fast can get the data that you need in the data warehouse, and it might be just small samples, but it's just important to get in a fast way access to the data, and then you just will work mainly on prototypes, and you will have like subject matter expert or a stakeholder at your company, but you can iterate on really fast. Is this something that will work? Yes or no? So you will mainly work through Google Sheets, so you don't want to build a fancy AI early on, because that actually might be fancy UI early on, because that actually might prolong the development cycle. And then eventually, when you're happy, or the SME is happy with the prototype that you have, you can provide a data dump, and you can go in the wild to the customers and try selling the application. So important things here is that you need to work from following the lean startup principles. Don't put too much focus on a lot of development, work with experience, so that you can see what works, what doesn't work, and also just make sure that it's easy to query your data. For example, if it would take a few weeks, if your developers are like really busy, go provide like fast data to your data scientist. You need to have like a new set of data coming in that's challenging, so therefore make sure that you have easy ways access to your data. If things go well, then the fancy AI application actually will be the product that your customers are using. So you have predictions coming in on a continuous basis, and then the question actually will be, or the predictions from good results. And then we have two types actually for testing it. If you're trying to predict the future, then you just wait till the future is happening, and you can compare the results. If you, for example, are doing more like labeling tests or classification tests, you can work through crowdsourcing approaches and have like labels validating your results. You provide automation scripts, and you are storing all these results in an accuracy database, which you then actually, or for example, showing on a monthly basis or a quarterly basis, all the stake. A lot of people might be interested in this. Data scientists might use this as a feedback loop, actually to improve their algorithm. It also might give like peace of mind for the higher people higher up in the company, for knowing that everything actually is working. And in this case, you're indeed providing backtesting, but the focus is more like on automation, repeatability, and reliability, because you don't want like each month that you have people like a whole week working actually on generating these reports. And you have also more time than actually for focusing for automating it, so you focus on reducing the time for generating this pipeline and the cost, and you also try to be proactive. If things don't look right, try to actually fix things beforehand, because otherwise you get to this situation where the customer eventually is saying like, will it keep working, and then why did it stop working? And then you actually should be able to trace back why is your fancy AI algorithm actually not doing anymore what it should be doing. And then it's important to have your logs available, knowing the rules that were applied for getting those results. You need to make sure that you have like important test cases for your important customers, if you can keep tracking the results for them, and maybe go back and see when certain things actually were breaking. And in this case, making sure that you actually can revert back to the previous version and make the customer happy again, and things that broke, you can actually use them as negative examples in your training set, that you actually can improve your algorithm. So in this case, you don't need to have a fancy UI for your data pipeline. It's just important that the people who will need to track all the different problems know how the logs look like. So you even just might use like tools like Badger Python there just to analyze all the different things. So this brings me to the lessons learned, also through my career. So new tools and technologies come out and will come out all the time. So sometimes you just might feel worried that you're not knowing all the latest stuff, but there are always various ways to solve the same problem, and sometimes all the tools might work, sometimes you need to dig into newer tools. And it's also always to understand the business case that you're solving and that you're just not doing it for fun, but eventually also just making the customer happy. So you can contact me further at mary@maplin.ca, and that was my presentation.
Can you please explain more about the accuracy database? It's the first time I'm hearing that term, and the accuracy database.
Okay.
What is the difference between that one and the database that are data lines?
Example might have like, so you're doing predictions, and then you can indeed store the results, and then you want to track over time, like, is my classification correct, yes or no? So then it's also just, so you have your ground truth, or you have data coming in from labels, and just will be storing that information in your accuracy database so that you easily can track over time when things might be going wrong. So that's, you can also just have that in Google Sheets, but that's like harder to track it. So it's better to have like a database available with all those results so that you can gain extra insights from that.
Just testing this. Okay, awesome. So I'll bring this now. People have questions? Oh, awesome.
Did you notice any difference between working with supervised, i.e. labeled data, and unsupervised?
Okay, so most of my work mostly has been like with supervised learning, but then indeed the challenge is like indeed getting your labeled data. So what we would have at one company was we would run cluster algorithms on like large sets of data, and then we still would actually have like, yeah, also as humans looking at it, trying to tag different classes to it and use that then actually as an input to like our supervised learning.
So I also have a question. So what is the stack that you would say is your like tool set? So it could be your favorite like libraries. I'm assuming Python, but I also know some people prefer R. But yeah.
It's I prefer like as database. I always prefer something where what I can query with like a SQL like query. So because like it's been a while. A few years ago, you would think like SQL is dying. But like you always see that it's coming back. So like a big database where you can query like a SQL-like way is what I prefer. And then indeed like Python, I prefer a lot. In some cases I also have worked a bit with R, but it just depends like which tools are available in there. And development itself on Linux.
And do you find that a lot of people like would, if you take a step back for big data, they would think Hadoop and that you can use a Hadoop system to kind of do your queries and that. But do you think that with like, part of this is like the power of computation now, do you find that you have to use like a parallel system or a cluster, or maybe it's just like one system with a GPU? Do you rely on cloud? Kind of.
It depends also like how big your company is and how big your support system is. And so what I prefer is like that you have like hosted solutions that take care of your big data so that you can sleep at night, don't need to wake up to restart your cluster. So that's always an important thing. So if you have those things available, indeed then it's great to go like with all those big data solutions. The challenge is just like, for example, if you're in a small startup, you don't have all the resources always to get those big things running. And then just sometimes in the early days, it might be easier to just get like access to like a SQL database to get your early results.
So following that, I'm just gonna hog this right now. Do you think that if you are, I think a lot of people here either maybe want to have a startup, might come from more of a startup background, what would you recommend for them where they lack the resources for say like a big cloud cluster and they're trying to do like a skimpier version of things basically?
What I always would say is like various cloud providers always have like credits available for startups. So I would always advise go shopping and then also look for those programs always like with programs that have like good evangelist programs available or resources available. And then otherwise I would say try to stick with the things you feel comfortable with or that you know that you can find extra people in, because it doesn't make sense to go with like something really fancy, and then if you want to grow, you don't find any people, because then you still need to switch your stack. So from that point of view, initially, sometimes even with text files, you can go a long way, and otherwise you just use a small SQL database and just see what's happening, and when things are growing, then you can worry about that. Because the problem is if you stick too much first on growing and don't have customers, then it's also like a challenge.
Anyone else have a question? Otherwise I can keep going. Cool.
I know from your previous talks that you work with Microsoft machine learning tools.
Yeah.
Did you work with other artificial intelligence stacks, and if you can compare like what's particular with each one?
Okay, so I am currently getting more into TensorFlow, but it's only like for the last week, so I've gone. Yeah, I've recently switched up, but what I have seen actually, like all those stacks now have like good strategies actually to index your models, to store your models in databases. So that's an important thing to have, that you easily can deploy your models, switch out your models. So that's always something you need to look for. Both TensorFlow and Azure Machine Learning Studio have it. And it's, for the rest, in the past I also have implemented machine learning algorithms myself, but I certainly would say avoid that because it's taking too much time. But for the rest, I just also need to dig a bit more into TensorFlow now. So before I can say like real judgments about it.
Cool. Does anyone else out there have a question? Cool. I have one more question. So this is a big thing I find, especially in my role, is reproducibility. Yeah. So what do you do? It could be to log your models or to basically be able to reproduce them, because I know how easy it is to just like tweak parameters, get great results, tweak them again, and not be able to always revert back. So I'd love, it could be source control, it could be just keeping notes on everything, but I'd love to hear your answer.
So years ago I built something for that. I just really made sure that I just kept all the different parameters, just storing everything. Then I was looking, the algorithm was always putting out like rules that have been triggered and like probabilities that were, so I just tried to store as much as possible. And the big challenge is also like you don't want to store your parameters in source control because you always want to have them different actually from your code, because you don't want each time you're training putting them in source control. So then I just like actually just stored everything on disk and just could go back, revert, and made sure that I had the combination available of my git commit. And then indeed I had all the different inputs and I just could swap the files out, and in that way could go back to previous versions. Because now there also exists more automated tools for it, but then I just implemented completely myself and actually just used Bash for it, so which was a fun experience. And it did its work, so that was the important thing.
Cool. Awesome. Yeah, so any other questions? Oh, cool. I was about to cut things off, but
I think you got no. Thank you so much for the presentation, Barry. I have a question about cleaning data. So, big part of, or big chunk of time that we spend building the data pipeline is cleaning data. Do you have any strategies or tools that you use? For one, I know Excel is something people use regularly, and OpenRefine, a Google product, is something that's being used. What would you recommend?
Okay, so what I mostly do is like looking for some rules, just implementing some rule-based systems. Sometimes yourself. Also, yeah, like I have some more experience with the Azure machine learning stack, so they also have tools available there actually for doing cleaning.
Okay.
So that's easy things that you can do. And for the rest, like also my previous company, we worked with some ASR there. We also had like, I don't know the library of it anymore, but we also had like some tools available. The most important thing is also that you're consistent actually for the cleaning. If you're doing the training, later on the prediction, you have the same cleaning algorithms that you're using.
The biggest challenge is like when we're building a data pipeline is we have multiple sources for data.
Yeah.
Then how do you really address that challenge? Do you have a special strategy to do that, or?
Just depends a bit. Like most of the time, like a lot of things you just can actually see like data that's too small or not, so just and remove those ones. And what I mostly do is like just also really looking at the data, looking how it looks like, making some histograms, and trying to find some logic in there. Sometimes it also just pays off to do like that little bit more manual work than immediately trying to jump into automation. And in that way you just can learn just about things that you actually otherwise might miss if you jump too fast into automation. So it's
awesome, yeah. So thank you so much, Mary, for coming and speaking. We can give one more round of applause. Oh wait, we have one more question.
Sorry. I'm Mary. I just have a question. How do you label the data? If you have like unlabeled data, so in that case, unsupervised learning is not the result is not that good. Yeah.
So we have used I've used like two approaches in the past. So one indeed would be like that you first apply unsupervised learning, get some clusters of data, try to label them in that way, and maybe still try to split it up. Or otherwise, you can also go more like a crowdsourcing route, so that you actually try to like find based on some logic some data, and then just send it out like things like mechanical Turk or like cauliflower, just in that way get some initial results. And what you also can do later on is like you have maybe applied a machine learning algorithm, just sending those ones back to labelers, validating those ones and getting those as extra inputs, and that eventually also will give you more data to label. Yeah, more data in your categories.
Great, thank you.
Yeah. So thank you very much, Mary.
Some promotion for
Yeah, for sure. Here, take this if you want it.
Okay, so also check out KW Intersection. So we come together like monthly, and we have like a mix of academic and theoretical related talks, either computer science, mathematics, sometimes also a bit of machine learning.
We're not competing groups, we're very different.
Yeah, our talks are one. Okay, so our next talk actually will be next Tuesday. That's our goal. Thank you.
Thank you.